Is the following statement true, that for all integers a, b, and c, if a divides b and a divides c, then a divides b minus c? Well, let's think of some examples first, right? What does divisibility mean? Well, it means that b is a multiple of a, or b can be written as a times something. Or a divides c is the same as saying c is a multiple of a, or c is equal to a times something. So let's look at a common a. Let's look at 5. Or no, let's start with 2, right? If a is 2, and you should think of multiples of 2. So 2 times 2, 2 times 3, 2 times 4, 2 times 5, so on and so forth, and let that be your b and c. So let's say 2 times 2, let's do 4, and let's have 2 divides 6, okay? So b is 4 and c is 6. And the reason this is true, again, is because 4 can be written as 2 times something, in this case 2, and 6 can be written as 2 times something, in this case 3. Okay, then let's look at 2 is equal to 4 minus 6. Okay, well, that's asking, can 2 divide negative 2? And the answer is yes, because negative 2 can be written as 2 times negative 1, where negative 1 is also an integer. It's super important that the right-hand side is an integer and the left-hand side are integers, as we've seen here. Okay, so 2 seems to work. Let's just do one more. Let's do 3. Let's take a is equal to 3, so 3 times 2, 3 times 3, 3 times 4. Let's do 3 times 3, let's do 9. And then let's do 3 times 5. Let's do 3 times 5 is 15. Let's do some bigger numbers just so we practice our math a little better. Of course, this is true because 9 can be written as 3 times something, or 3 times 3. And this is true because 15 can be written as 3 times something, or 3 times 5. Okay, great. Now let's have a look at 3 divides into 9 minus 15, which is going to be the same as saying 3 divides into negative 6. And this is, of course, true because negative 6 can be written as 3 times something, and our something here is going to be negative 2. Negative 2 is an integer. So we know that this statement is true, which means that probably this statement, our original statement, is likely true. So let's try proving it. Right, before we prove it, we need to know our definitions of divisibility. Divisibility is simply going to be, for example, if we have something like a divides b, that's basically saying that for integers a and b, where b can be written as a times k for some k that's also an integer. It might be better to actually write k here, a comma b comma k, but I like to divide them so you can more clearly separate your thought. Okay, now we can start writing our proof. So this is a for all proof, so how do we start? We start with let. What do we let? We let a, b, c be integers such that a divides b and a divides c. Okay, fantastic. What does it mean for a to divide b and a to divide c? Let's write that in math terms. So we can then say, then b is equal to a times m for some integer m. And we can then say c is equal to a times n for some integer m. You can, of course, merge sentences as long as it's grammatically correct. Great. Okay, we've exhausted everything we should define. I think we're prepared to now tackle the then statement, our Q. So we can then ask ourselves, okay, then b minus c is going to be the same as am minus an, which is going to be the same as a multiplied by m minus n. Okay, and this is where we can acknowledge where m minus n is an integer. So a does divide a times m minus n, and, or we can say, yeah, we can say and, or we can, no, let's say, so a divides n, and because of this, a does in fact divide b minus c. So there we go, we've proven the statement. Once again, why can we jump from here to here? because when you're saying something divides something, with the examples we noticed, I explicitly wrote out, if we have 2 divides 4, its 4 can be written as 2 times some integer. I'm just going to call this z, right? So in other words, we're asking 2 divides 2 z, right? Same thing with 3. When we looked at 3 divides 6, we're basically asking, well, 6 can be written as 3 times something, 3 times some sort of integer. So we're basically saying 3 is divisible, or 3 divides 3 times an integer, right? So we're looking to get something in this form where what we have on the left, we find on the right as well in both cases, or in all cases in our case. And then we can argue that everything else is just an integer, right? So that is why we can make a leap from here to here, and from here, obviously, to here.